Time. It's the one companion every living thing carries, yet no one has ever touched it. We hear its footsteps in the ticking of a clock, we see its shadow in the setting sun, and we feel its weight when moments of joy vanish too quickly. But what really is time in the universe? Tonight, let's drift slowly into this mystery. I'll guide you through how humans first noticed it, how the cosmos measures it, and how it shapes our very lives. Let the words move like a soft current, carrying you deeper into wonder, the quiet mystery of what we call time. Time slips by whether we notice it or not. It's the silent rhythm that makes leaves fall, rivers flow, and faces grow older. Yet for something so constant, it remains invisible. People can see space, touch matter, even hear sound, but time refuses to be held. Some have wondered, is time real or just a trick of the mind? When we say yesterday, we mean a memory. When we say tomorrow, it's only imagination. What exists is the fleeting instant we call now, and even as we speak of it, it's already gone. We try to trap time with numbers, calendars, or machines, but time itself slips away untouched. It's like trying to hold water in your hands. No matter how tightly you grip, it escapes through the smallest cracks. This mystery has puzzled thinkers for thousands of years. Was time created with the universe, or has it always been flowing without beginning, without end? These questions are not just science, they are deeply human, because all of us live under time's shadow, whether we fight it or surrender to it. When a child plays, time seems endless, but when a person waits in silence, seconds turn into mountains. The same clock ticks in both rooms, yet the experience feels worlds apart. That's why time is more than numbers. It's emotion, perception, and story. The physics of time may speak in equations, but our hearts measure it in sighs, in laughter, in moments that never return. And maybe that's why we call it mysterious, because time is not just outside of us, it's inside us too. Scientists today use atomic clocks to measure time down to billionths of a second, but the paradox remains. Why does time only move forward? Why can we remember the past but not the future? Why do all things grow older but never younger? These are riddles that sit at the very foundation of existence. The universe itself seems to obey this one-way rule, though no one fully knows why. Some call it the arrow of time, others call it destiny. As we begin to walk deeper into this story, we notice how humanity's first attempts to grasp time were not about theories or machines, but about survival. Before clocks, before science, people looked to the skies for answers, the rising sun, the changing moon, the returning stars, all whispered that time was real, even if unseen. And from those whispers came our first calendars, our first rhythms of life. How ancient stargazers first tried to measure it. Long before cities or electricity, people lived by the open sky. Every night they saw stars sweep across the heavens, and every morning the sun returned, never failing. Ancient stargazers noticed that the heavens had a rhythm, days, nights, seasons, all repeating with steady patience. This became their first clock, a cosmic one written in fire and light. Without these cycles, farming, travel, even survival itself would have been impossible. The sky was not just beautiful, it was the world's first teacher of time. Imagine standing thousands of years ago on desert sands, watching shadows stretch as the sun rose higher, then shrink as it sank again. To those people, shadows weren't just shapes, they were rulers of the day. Every tilt of sunlight marked a step forward in time. Ancient stargazers carved tall stones, not for worship alone, but to catch the sun's rays and track its path. What we now call Stonehenge, or the pyramids, held secrets of calendars, built with eyes turned skyward. The moon also became a faithful guide. Its shape waxed and waned with perfect rhythm, telling humans when to plant, when to harvest, and when to rest. In some cultures, entire years were counted not by the sun, but by the moon's turning face. Imagine the awe of realizing that time itself could be written in the heavens. Every crescent, every eclipse was not just light, it was a reminder that the universe kept perfect memory of every moment. But these ancient astronomers didn't just watch, they listened. The sound of cicadas in summer, the migration of birds, the flooding of rivers, nature itself sang the song of time. These patterns told them that the passing of days was more than chance, it was law. And so calendars were born. Some carved on bones, others painted on cave walls, each one a fragile attempt to hold the rhythm of the infinite sky. It was humanity's first great dance with time. The beauty lies in how those old observers, with no telescopes, no satellites, still found truths that remain with us. They discovered that the universe runs on cycles and that those cycles could be trusted. Today we see them as primitive. Yet without their courage to look up, measure, and believe, we would never have stepped toward the science of time. Their eyes were the first clocks, and their faith in the sky lit the path forward. The sun's rise and fall as the earliest clock. Before watches, before hours, the sun ruled all human life. Its rising brought work, its setting brought rest. For our ancestors, the sun was more than light. It was time itself. Its golden arc across the sky became the first universal clock, one that all people shared no matter their land or language. With every dawn they reset their lives, with every dusk they surrendered to darkness. The sun was the heartbeat of the day, beating endlessly without fail. When humans learned to watch shadows cast by poles and stones, a new kind of measurement appeared. Sundials were born, simple yet powerful. A stick in the ground told you the hour, not in numbers, but in shadows. The longer the shadow stretched, the closer the day came to its evening end. This was genius in its simplicity. Without gears or batteries, only the sun itself, humanity could divide the day into smaller pieces. And so, the rhythm of work and rest gained more structure. But the sun had its moods. Clouds, storms, or the long darkness of winter often hid it. People learned that though the sun was steady, its path shifted. Days grew longer, then shorter in an endless loop. This taught them about seasons, the deep clock within the year. Farmers relied on this great cycle, knowing that the tilt of sunlight determined life or famine. The sun was not only their day counter, but also their guardian of survival. The sun also gave humans their first sense of the sacred in time. Many cultures worshipped it, not simply for warmth, but because it held the rhythm of existence. Temples faced its rising, rituals followed its movement, kings and priests tied their power to its eternal return. In this way, the sun was not just physical, it was spiritual time, binding human hearts to the heavens. Its daily return promised order in a world that often felt uncertain. Even today, with all our clocks, our schedules still bow to the sun. We rise in the morning, we rest at night. No matter how modern we feel, the sun still commands the great circle of human time. It is the most ancient, unbroken clock, older than calendars, older than science. The sun continues to remind us, time begins each day with light and ends with darkness, only to rise again. The moon's silent cycles shaping months. If the sun was the ruler of days, the moon became the keeper of months. Its silver face waxed and waned in a slow, graceful rhythm that guided human life long before numbered calendars. From a thin crescent to a glowing circle and back again, the moon gave people a visible way to measure longer stretches of time. One cycle of its phases became 1 month, a rhythm written in the very sky above. Unlike the sun, the moon seemed closer, more personal. Its glow followed travelers at night, watched over fields, and even influenced tides. To ancient people, the moon was a silent companion, marking not just time, but emotion. Festivals, hunts, and harvests were tied to its phases. Full moons often meant gatherings, celebrations, or rituals. New moons brought beginnings. Its changing face was not random, it was the language of time spoken in silver light. Cultures around the world built calendars on lunar cycles. The Hebrew calendar, the Islamic calendar, even early Chinese records all traced months to the moon. This meant time was not only about the sun's grand arc, but also the moon's more intimate rhythm. And because lunar months didn't perfectly match solar years, cultures learned to add or adjust days, proving that even then, humans wrestled with the puzzle of keeping time balanced. There's something almost haunting about how humans, thousands of years apart, felt the same awe under the same moon. A farmer in Mesopotamia, a sailor in Polynesia, a child in Egypt, all lifted their eyes and counted nights by its phases. This shared rhythm connected humanity across distance and generations. In this sense, the moon gave not just months, but also unity, a reminder that everyone lived under the same patient cycle of light and shadow. Even now, long after digital clocks have replaced lunar counts, the moon still shapes us. Its pull on tides continues to regulate Earth's oceans. Its phases influence traditions, festivals, and even moods. People still gather to watch eclipses or marvel at a supermoon. The moon remains a clock, not just of days, but of wonder, whispering that time can be both practical and poetic all at once. The stars painting seasons across the sky. Above both sun and moon, the stars gave humans their longest calendar. Each season carried its own constellations, Orion in winter, Scorpius in summer. By watching which stars rose at dusk or set at dawn, ancient stargazers knew when rains would come, when rivers would swell, when it was time to sow or reap. The stars painted a map of time stretched across the heavens, one that repeated endlessly with the patience of eternity. In Egypt, the rising of Sirius marked the flooding of the Nile, the lifeline of the land. In Greece, constellations told farmers when to plant their crops. Polynesian navigators read stars like a clock, guiding them across oceans. To them, the night sky was not random glitter, it was a calendar written in fire. And because these patterns returned every year, they could trust them as faithfully as the sunrise itself. The stars were the guardians of the year's great rhythm. Yet there was magic in this practicality. Looking up, humans didn't just see tools, they saw stories. They linked stars into hunters, lions, and maidens. Myths were born in those constellations, tying human imagination to the flow of seasons. Time was not only measured, it was storied. When the hunter Orion returned, so did winter. When the Pleiades rose, it was the season for planting. Myths kept memory alive, turning time into tales that could be passed from one generation to the next. As cultures advanced, these star calendars became precise. Ancient observatories tracked equinoxes and solstices, aligning monuments perfectly with star paths. Stone, wood, and fire were arranged to mirror the heavens. It wasn't superstition, it was science in its earliest form. By listening to the stars, humans learned that time wasn't chaos, but order, a cosmic rhythm that could be counted, trusted, and lived by. The night sky was humanity's first library of time. Today we know the stars are suns themselves, burning across unimaginable distances. Yet when they rise and fall in their yearly pattern, they still remind us of the same truth. the universe itself carries a clock larger than any we build. The seasons turn, the stars return, and humanity still finds its place in that rhythm. It is the grandest reminder that time doesn't just pass on Earth, it flows through the entire cosmos, painted in constellations above. Sand, shadows, and water clocks of old worlds. Before gears and glass, time was measured with simple but ingenious tools. A bowl of water with a hole at the bottom, dripping drop by drop until it emptied. A tall column of sand trickling steadily from top to bottom, or a shadow slowly sliding across carved stones. These were the world's first mechanical clocks, silent instruments that turned the invisible into something you could watch. People could now divide the day more finely beyond just sunrise and sunset. The sand glass, or hourglass, became a powerful symbol of time's flow. Every grain represented a second slipping away, impossible to stop or return. Sailors used them to measure shifts at sea, monks used them for prayer hours, and workers used them to keep order in their tasks. There was something strangely poetic in these devices, time not as a number on a dial, but as something physical, flowing, vanishing, always moving forward. Water clocks, or clepsydras, were equally brilliant. The Egyptians, Greeks, and Chinese built intricate ones, some even designed with gears and figures that moved as the water flowed. Imagine watching a quiet stream inside a carved pot, knowing that each drop was a step forward in the march of time. These devices turned nature itself into a timekeeper, showing that humans had learned to borrow rhythm from flowing elements. But shadows, cast by sundials, remained the most widespread. A single stick in the ground could tell you how far the day had travelled. Entire cities arranged their routines around these shadows. They worked only when the sun shone, yet they reminded people that time was woven into light itself. To measure a shadow was to measure the day's heartbeat. Even in their simplicity, these tools taught people something profound. Time is never still, always slipping into silence. Though primitive compared to today's atomic clocks, these devices carried a deeper truth. They taught humans to see time not as an abstract idea, but as something they could touch, measure, and live by. Every drop of water, every falling grain of sand, every moving shadow whispered the same lesson. Time flows and nothing can stop it. And from that flow, humans built their civilizations. How pendulums taught us precision. Centuries passed before another great leap in timekeeping came, this time swinging back and forth. In the 1600s, Galileo noticed something remarkable. A swinging lamp in a cathedral seemed to take the same amount of time with every swing, no matter how wide or small the arc. This discovery would later inspire Christian Huygens to build the first pendulum clock. Suddenly, humans could measure minutes and seconds with precision never before imagined. The pendulum clock changed the world. Cities could now synchronize bells, factories could regulate shifts, and explorers could chart seas with greater accuracy. Before pendulums, time was loose and approximate. After them, it became strict and exact. Imagine the sound of a pendulum swinging in a quiet room, tick after tock, like a heartbeat made of wood and brass. For the first time, time itself seemed captured, chained to steady swings. What made the pendulum so powerful was its predictability. Gravity and length determined its rhythm, not chance. A pendulum of a certain size would always swing the same way. It was nature's gift, harnessed by human hands. This precision allowed scientists to test theories, measure experiments, and build the foundations of modern science. Without pendulums, physics and astronomy would have remained half-blind to time's finer details. Yet, pendulums also had limits. They worked best when still, indoors, away from storms or shaking ships. But for centuries, they remained the gold standard of accuracy. They were not just tools, they were symbols of the new scientific age, where the universe could be measured, predicted, and ordered. The pendulum became a bridge from the flowing sands of old to the sharp ticks of modernity. Today, pendulums still swing in some old towers and museums, gentle reminders of a time when humanity's dream was to tame the seconds. They whisper to us that time can be disciplined, even if only briefly, by the steady hand of science. And in their rhythmic dance we see a deeper truth. Time may be endless, but humans always seek a way to count its steps. The invention of seconds and minutes. There was a time when hours were enough. Days divided into halves, then quarters, then twelfths. But with pendulums and growing precision, humanity wanted smaller slices. Minutes were born, 60ths of hours. Then came seconds, 60ths of minutes. What once was a broad sweep of sunlight became fine divisions, so small you could almost hear them. This invention changed not only science but the human experience itself. With minutes and seconds, life became sharper. Appointments could be set not just for the morning, but for 10:15 sharp. Ships could calculate longitude by the difference in time between port and sea. Musicians could play in perfect rhythm. Scientists could measure speed and acceleration. Doctors could take pulses with accuracy. The world became more ordered, yet also more demanding. Time was no longer only nature's rhythm. It was a ruler held over human life. But something subtle shifted. When people lived by days and seasons, time was slower, softer. With minutes and seconds it became urgent. Schedules, deadlines, and pressure followed. The invention of these smaller units gave humanity incredible power, but it also introduced stress. Every lost minute became noticeable, every wasted second a source of guilt. Time, once a companion, became a master to be obeyed. And yet without these fine divisions, the modern world would not exist. Trains could not run, factories could not function, space missions could not launch. Seconds and minutes became the invisible gears of civilization. They made possible both the chaos of modern speed and the miracles of modern achievement. Humanity had turned time into a tool so sharp it could cut through eternity. When you glance at a clock and see its seconds ticking, you are touching this invention. It is the echo of centuries of human effort to tame the flow of existence. And perhaps as we live in this ticking cage, we should remember every minute is not just a measure, it is a choice of how we live it. The heartbeat of Earth that guides our days. Long before pendulums, even before sundials, Earth itself carried the greatest clock of all. Our planet spins once every 24 hours, giving us day and night. This rotation is the heartbeat of time on Earth, steady and ancient. Every sunrise and sunset is the tick and tock of a cosmic pendulum that has been beating for billions of years. Without it, time as we know it would not exist. But this heartbeat is not perfectly steady. Earth's rotation is slowly slowing down. Tides, pulled by the moon, drag against Earth, making days longer by tiny fractions. Millions of years ago, a day was only 22 hours long. Millions of years from now, it may be 25. When we add leap seconds to our atomic clocks, it is because Earth's heartbeat does not always match the precision of our machines. Even the planet itself reminds us that time is alive, not fixed. This rotation guides not just light, but life. Plants open and close with the sun, animals hunt by night or day. Humans feel their bodies rise and rest with this rhythm. Our very biology is tuned to Earth's spin. Without this rotation, without the alternation of light and darkness, life itself might never have evolved. Time on Earth is not only measured by clocks, it is written in every cell of our being. Imagine standing on a beach, watching the horizon glow as the sun rises. That moment is more than beauty. It is the result of Earth's great rotation, carrying us forward through space. Every dawn is proof that our planet spins, steady and patient, dragging us through time whether we notice or not. We are passengers on a giant clock face, carried along by its eternal turning. This planetary heartbeat connects us to the cosmos. The same rhythm that guided ancient farmers still guides us, though now we carry phones and watches. No matter how advanced we become, we cannot escape this turning. Each day is a gift of the Earth's rotation, each night a reminder of its pause. It is the most faithful, the most ancient of all clocks. How gravity whispers into the flow of time. For most of history, humans thought time was the same everywhere. But the universe had a deeper secret. Gravity, the invisible force that holds planets and stars, also bends time itself. This was Einstein's great revelation. Time does not tick equally in all places. Near a massive object like Earth or a star, time runs slower. High above, where gravity is weaker, it runs faster. Time itself is woven into the fabric of space, curved by the weight of matter. This means that astronauts in orbit age a tiny bit faster than people on Earth. The difference is so small it can only be measured with atomic clocks, but it is real. The stronger the gravity, the slower the flow of time. Imagine standing near a black hole. Its immense pull would stretch seconds into eternities. To an outside observer, your clock would nearly stop. Gravity is not only pulling on your body, it is pulling on your very existence in time. This discovery reshaped physics. It explained why light bends near stars, why planets move the way they do, why the universe is not flat but curved. Time is not a straight line but a flexible fabric, and gravity is the hand that shapes it. The universe is a vast stage where both space and time dance together, inseparable, woven into what we now call space-time. And though this sounds abstract, it touches daily life. GPS satellites must correct their clocks because gravity affects them differently than on Earth's surface. Without accounting for this, navigation would fail. So, every time you use your phone to find a route, you are relying on Einstein's truth. Gravity bends time, and technology must listen to that whisper. There is something humbling in this thought. What we once believed to be universal and absolute turns out to be fragile, local, and shaped by invisible forces. Time itself, the very foundation of experience, is not the same everywhere. It bends, slows, quickens, depending on where you stand in the universe. And so in the deepest silence, gravity whispers into the flow of time. Einstein's vision that time bends like fabric. For centuries, people thought time was steady, ticking the same for all. Then came Albert Einstein, who shattered that belief. He showed that time is not rigid, but bends, stretches, and curves, woven together with space like threads in a fabric. This was not just theory, it was a revolution. Suddenly, time was not a backdrop to the universe. It was part of the stage itself, shaped by stars, planets, and motion. Einstein's vision meant that the universe was dynamic. Imagine space and time as a great invisible sheet. Place a heavy ball on it and the sheet dips. Smaller balls nearby roll inward, not because of invisible strings, but because the sheet itself is curved. In the same way, planets move not because they're pulled by some magical rope, but because space and time curve around the sun, and if space bends, so does time. This bending of time explained puzzles that baffled astronomers. Mercury's orbit, for example, made strange shifts that Newton's laws couldn't fully explain. But in Einstein's curved space-time, it all made sense. Time and space were no longer separate. They were married, inseparable, moving as one. The cosmos was not a static machine, but a living fabric, rippling, stretching, responding to mass and energy. And what does this mean for us? It means your clock, your heartbeat, your very sense of now is tied to where you stand in this cosmic fabric. The ground beneath you curves time differently than the stars above. Even your movement changes how fast your seconds pass. Time is no longer absolute. It belongs to the universe, bending to its will. There's a quiet beauty in this. Instead of cold mechanical ticks, time becomes a living dance with the cosmos. Einstein taught us that we are not standing outside of time, observing it. We are woven into it, shaped by it, and carried by it. And this vision changed not only science, it changed the way we understand our very existence. Why moving faster changes how you age. One of Einstein's strangest predictions was that speed changes time. The faster you move, the slower your time flows compared to someone standing still. It sounds impossible, but experiments have proven it again and again. This is called time dilation, and it means that motion itself bends the river of time. Imagine two people. One stays on Earth, the other travels near the speed of light. When they reunite, the traveler will have aged less. This is no fantasy. In labs, scientists have flown atomic clocks on airplanes and found that they tick differently than those on the ground. Astronauts orbiting Earth live seconds less than those below. The effect is tiny at our speeds, but at extreme velocities, it becomes dramatic. In a spaceship moving near light speed, a year for the traveler could be decades for those left behind. Speed bends time, stretching seconds like elastic bands. This truth creates paradoxes that stir the imagination. Could you travel to the future by simply moving fast enough? In theory, yes. Though no ship today can approach light speed, the math is clear. Time would slow for you while the universe outside would race ahead. You'd return home to find the world aged without you. What feels like a year for you could be centuries for others. But here's the haunting part. The opposite isn't possible. You can't move slower and reverse time. Speed only slows your clock, it never turns it back. The arrow of time remains unbroken, even in the strangest scenarios. This reveals a deep truth. Time is not equal for all, but it always flows in one direction. Each path through the universe carries its own rhythm. So when you walk, drive, or fly, you are already experiencing this. Tiny differences, immeasurable to the naked eye, ripple through your seconds. Every heartbeat is not quite the same as another's. We are all time travelers, not in leaps, but in delicate differences shaped by how we move through the cosmos, the strange dance of twins in relativity. This idea of time slowing with speed gave birth to one of physics' most famous thought experiments, the twin paradox. Imagine two twins identical in every way. One remains on Earth, the other boards a ship and travels near light speed into space. When the traveling twin returns, they find something shocking. The twin on Earth has aged more. Though they shared the same beginning, their clocks no longer agree. It sounds like a paradox because each twin sees the other as moving. Shouldn't both age slower? The key lies in acceleration. The traveling twin must turn around, slow down, and speed up again. That break in symmetry creates the difference. Their journey through space-time is curved differently than the one who stayed behind. The universe keeps strict account of these paths, and when they meet again, the truth shows itself in their faces. This thought experiment is not just philosophy, it has real roots. Particle experiments have shown unstable particles moving at high speeds live longer than expected. Their decay slows down, exactly as relativity predicts. Nature itself agrees. The faster the journey, the slower the clock inside. The twin paradox may never be tested on humans, but the universe whispers its truth through every particle that rushes through space. The story of the twins touches something human in us. It asks, what would it feel like to leave Earth, only to return and find everyone older, cities changed, history past? The loneliness of traveling through slowed time is as profound as the physics itself. Time dilation is not just math, it is a window into the fragile link between motion and memory. So the paradox teaches us that time is not fixed like rails on a track. It is more like a river, flowing differently depending on how you move through it. The twins' strange dance is a reminder. In this universe, even siblings can live through time differently, though their hearts once beat in perfect unison. How satellites prove time isn't equal everywhere. We often think of relativity as distant and abstract, but it quietly runs our daily lives. Satellites orbiting Earth, especially those in the GPS network, tick differently than clocks on the ground. High above, gravity is weaker and speeds are higher, so time flows differently. If engineers ignored this, GPS would drift miles off every day. That means every time you check your location on a phone, you are seeing Einstein at work. Each GPS satellite carries atomic clocks of astonishing precision, but those clocks would be useless if not corrected. The Earth's gravity slows them slightly compared to clocks on the surface, while their speed quickens them. Combined, the difference amounts to microseconds each day. That may sound tiny, but in the language of satellites, microseconds mean kilometers of error. Without relativity adjustments, navigation would collapse. This shows how the universe does not care about human convenience. Time is not equal everywhere. It stretches and shrinks depending on where you stand. High in orbit, a second is not quite the same as on the street below. The fact that your morning drive depends on this cosmic truth is both humbling and beautiful. The dance of satellites proves that physics is not only in the stars, but in your pocket. The wonder deepens when you realize this is universal. On Mars, clocks would tick differently than on Earth. Near a black hole, differently still. Everywhere in the cosmos, time carries its own local rhythm. And yet, through equations and patience, humans learn to predict and adapt to this hidden truth. Satellites are not just machines in the sky, they are proof that time is flexible and that humanity has learned to live with its bends. Next time you use a map app, consider it a quiet handshake with Einstein. You are benefiting from one of the greatest insights in history, turned into practical daily magic. Every journey guided by GPS is also guided by the invisible stretch and pull of time itself, balanced with care so you can find your way. The ticking of atomic clocks beyond all doubt. After sundials, pendulums, and gears came a new master of time, the atom itself. In the mid-20th century, scientists discovered that atoms vibrate at incredibly stable frequencies. By measuring those vibrations, they built atomic clocks, devices so precise they lose less than a second over millions of years. These clocks became the guardians of modern time, keeping every second sharp and unyielding. Atomic clocks work by listening to the resonance of atoms, often cesium or rubidium. Each atom acts like a tiny pendulum, swinging not with gravity but with quantum certainty. Imagine a rhythm so perfect it never drifts, no matter the weather, no matter the place. This rhythm became the standard for defining the second itself. Time was no longer measured by Earth's rotation, but by the heartbeat of the atom. This shift was monumental. For the first time, humans could create a clock more reliable than the planet itself. Atomic clocks run our internet, our satellites, our financial systems, even our power grids. Every digital network you touch depends on their silent precision. Without them, modern civilization would dissolve into chaos. Timekeeping became not just a science, but a foundation of society. Yet there is something almost spiritual about it. Deep inside matter, at scales invisible to the eye, lies a rhythm so steady that it can govern the world. The universe itself provides these vibrations, untouched by human hands. By listening to atoms, humanity learned to anchor its seconds to the deepest laws of nature. It is as if time's truest voice was hidden within the smallest building blocks of reality. And still, even atomic clocks remind us that time is slippery. They confirm Einstein's predictions, showing how time drifts differently depending on gravity and speed. With every tick, they prove the universe's strange truth. time is not absolute, not equal, but relative and alive. In the ticking of these silent guardians, we hear both certainty and mystery, precision beyond doubt, and questions beyond imagination. Why GPS only works when we correct time stretch? When you look at your phone and see a little blue dot showing where you are, it feels simple. But hidden beneath that dot is one of the greatest achievements of science, GPS. Those satellites high above Earth rely on atomic clocks, yet their clocks tick differently than ours on the ground. Why? Because both speed and gravity bend time. Without corrections, GPS would be useless within hours. Your map would drift by miles, sending you into rivers instead of roads. Each GPS satellite orbits at thousands of kilometers per hour. Their motion slows their time slightly, but the weaker gravity up there makes their clocks tick faster than on Earth. The two effects don't cancel, they combine. So, engineers carefully adjust them, keeping everything synchronized with astonishing precision. Every turn you take while driving, every plane navigating across the ocean, every ship finding its port, depends on these tiny time corrections whispering across space. Think of the wonder here. A theory imagined by Einstein over a century ago now guides your daily life. What once sounded like abstract equations, time bending with speed and mass, has become practical reality. Without relativity, there would be no GPS, and without GPS, modern life would unravel. Transport, communication, even financial systems rely on it. All of this because humans learned that time is not equal everywhere. This truth connects us deeply to the universe. You are not just living by human clocks, you are guided by cosmic time itself, curved by Earth and corrected by satellites. Every step you take with a phone in your hand is part of a grand conversation between atoms, orbits, and gravity. The hidden choreography of relativity touches your footsteps even when you don't notice. So next time you glance at a map app, pause for a moment. That little blue dot is more than convenience. It is a reminder that time bends, space curves, and humanity has learned to listen to the universe well enough to find its way home. The arrow of time that never turns back. There's something we all sense, but rarely question. Time only flows forward. You can drop a cup, and it shatters, but never the reverse. We grow older, never younger. Memories are of the past, never of the future. This one-way flow is called the arrow of time, and it is one of the most profound mysteries in science. Why should time have a direction at all? The laws of physics on paper don't demand it, yet in life it is inescapable. This arrow shapes everything about existence. It gives us beginnings and endings. It makes stories possible. Without it, there would be no history, no progress, no meaning in change. The arrow of time is the invisible current we all ride, whether we drift or struggle. But where does it come from? Scientists believe the answer lies in entropy, the measure of disorder. The universe tends toward disorder, and in that tendency, time gains its forward push. Entropy is why smoke spreads but never gathers back, why ice melts but doesn't refreeze by itself, why we remember yesterday but not tomorrow. It is the reason time feels like an unbroken march. Without entropy, perhaps time would wobble or circle. But because disorder always increases, time always points ahead. It is less like a circle and more like a river flowing from order to chaos. This idea is haunting but also comforting. It explains why loss feels final, yet also why growth is possible. Every moment, every heartbeat, every sunrise belongs to this arrow. We cannot step back no matter how much we wish to. Yet that also means every new second is uncharted, a fresh chance born from the arrow's unstoppable journey. So, when we speak of time, we are really speaking of this one-way path. The arrow that never bends backward is both our greatest limit and our greatest gift. It ensures that life is not stagnant, but always moving, always becoming. We may not know where the arrow leads, but we know it never turns back. Entropy, the quiet painter of decay. Entropy is not a word most whisper at bedtime, yet it paints everything around us. It is the slow wearing of stones, the fading of memories, the cooling of stars. Entropy is disorder, spreading like ink through water, never reversing. It is the hidden law that ensures time moves forward, that nothing remains perfectly ordered forever. Even galaxies spin toward greater chaos. Even suns will one day warm. But entropy is not just destruction. It is change. Without it, fire would not burn, rivers would not flow, life would not grow. Entropy powers the universe's great unfolding. It takes energy from places of order and spreads it into new forms. The reason you can sip warm tea, the reason stars shine, the reason your heart beats, all are gifts of entropy. Decay is not only ending, it is transformation. Imagine an hourglass, its sand falling. The top grows emptier, the bottom fuller. That imbalance is entropy at work, balancing itself until both sides are even. The universe, too, seeks this balance. From the Big Bang's hot, ordered state, it has been spreading, cooling, expanding, becoming more disordered with every passing second. Time itself is drawn along by this spreading disorder. There's something quietly poetic in this. Entropy means perfection cannot last, but it also means new patterns always emerge. The petals of a dying flower feed new soil. The collapse of stars creates heavier elements. The end of one form gives birth to another. Entropy whispers that time is not cruel, but endlessly creative. Decay is also renewal, written in the slow handwriting of the cosmos. So when we look at entropy, we should not only see endings, we should see the painter's hand, shading life with impermanence, turning order into story. It is the reason time flows, the reason life changes, the reason beauty feels fleeting. Entropy is not the enemy of life, it is the backdrop that makes life precious. Why broken eggs tell us no return exists. Take an egg, drop it on the floor. In an instant, it shatters into countless pieces. We all know one thing, it will never jump back together. This simple truth reveals the arrow of time in the clearest way. Nature allows one direction, order into chaos, but never the reverse. A broken egg is more than a kitchen accident. It is a lesson about the universe itself. Why is it this way? Because the shattered pieces represent more possible states than the whole egg. Disorder is easier than order. Entropy grows. The laws of physics allow molecules to scatter, heat to spread, structures to collapse. But they never push the other way. The egg's brokenness is the universe's preference for disorder made visible. It is the everyday proof of cosmic laws. This truth explains why memory works as it does. We recall the egg before it fell, not after it broke. Our brains themselves are bound by entropy, holding images of the ordered past but not the unordered future. Every photograph, every history book, every scar is a testimony to this one-way rule. We can look back but never forward, because the arrow points only one way. And yet, in this everyday tragedy lies beauty. If eggs never broke, if things never changed, there would be no growth, no stories, no life. The irreversibility of time is what makes moments precious. Once lived, they cannot be remade. A laugh, a kiss, a goodbye, like the egg, they shatter into memory and cannot be reassembled. And that makes them treasures, not burdens. So the next time an egg breaks in your kitchen, pause. See not only the mess, but the law of the universe playing out. The egg will never come back together, and neither will yesterday. But that is not sorrow, it is the gift that makes today real, alive and irreplaceable. The deep link between memory and the future. Time is not only about clocks and stars, it is also about minds, We humans know the past because we carry memory, and we long for the future because we imagine. These two powers, remembering and anticipating, are the way we ride the arrow of time. Without memory, there would be no sense of yesterday, and without imagination, no hope of tomorrow. Our experience of time is tied to what we can recall and what we can dream. Neuroscience shows this link clearly. The same parts of the brain that store memory also light up when we think about the future. To remember is to rehearse, and to imagine is to remember in advance. In this way, memory and the future are twins, bound together. They are not opposites, but reflections. What we have seen gives shape to what we expect, and what we expect shapes how we act. But here lies a mystery. Why does memory work only backward? We never remember tomorrow. The answer, again, lies in entropy. The past is ordered, recorded, stable. The future is open, chaotic, unformed. Our minds can only store what has already left its mark. So we build stories from fragments, hoping to guess the pattern of what lies ahead. In this way, memory becomes a compass for navigating the unknown. And yet memory is imperfect. We forget, we distort, we reshape. Our sense of time is built not on flawless records, but on fragile echoes. Sometimes memories feel longer than they were, sometimes shorter. Our perception bends time like Einstein's fabric, only in the theatre of the mind. And through this bending, we create meaning. Memory is not only about truth, it is about story, giving weight to the flow of time. So the deep link between memory and the future is not scientific alone, it is human. To live is to look back and forward at once, to hold yesterday's fragments and tomorrow's hopes. And in that act we make time our own. The universe may measure seconds with atoms, but we measure it with memories and dreams, the vast age of the universe itself. When we talk about time on Earth, we think in years, decades, maybe centuries. But the universe asks us to stretch further, far, far beyond human scales. Scientists now know that the universe is about 13.8 billion years old, a number so vast it feels almost meaningless, yet every star, every atom, every breath we take lives inside that unimaginable span. The universe is not young, yet not finished. It is ancient, yet still unfolding. This age was not guessed, but measured. By studying how galaxies race apart and how the faint glow of cosmic background light lingers, astronomers pieced together a timeline. Like detectives, they followed clues left in radiation, in expansion, in starlight traveling for billions of years. Every flicker of light tells a story of how old the cosmos is. Time is written across the sky like a diary, if only we have the patience to read it. When you sit under the stars, you are really sitting under history. The starlight touching your eyes may have begun its journey before humans even existed, before Earth itself was fully formed. That light carries a clock stamped into it, whispering the universe's age in each photon. To look at the sky is to look into a time deeper than imagination, where billions of years roll by like quiet waves. What's humbling is how short our lives are against that scale. 100 years is a heartbeat, civilizations are sparks, yet within that shortness we can still sense the vastness. The human mind can stretch beyond its years, feeling awe at the numbers. In this way, the age of the universe does not make us small, it makes us part of something vast and mysterious, part of an ancient story still being written. And the most striking thought of all, if the universe has lived 13.8 billion years, what will it look like 13.8 billion more into the future? Time stretches ahead as endlessly as it stretches behind. We stand in the middle of eternity, watching, measuring, and wondering. The moment the first second ever ticked. There was a time when time itself began, or at least when it became meaningful. The Big Bang. In that first fraction of a second, the universe was too hot, too dense, too chaotic for clocks or rhythms. But as it expanded, cooled, and calmed, the very first second of cosmic history ticked. That first second is unlike any other because it birthed all the seconds to follow. In that heartbeat of creation, particles formed, forces separated, light began to move freely. Physics as we know it came alive. Time and space, inseparable, poured outward in every direction. The universe, in its first second, was already on its way toward stars, planets, and life. Without that second, there would be no story to tell. It is the root of all beginnings. Scientists cannot see that first second directly, but they can trace its echoes. The cosmic background radiation, the faint hum of leftover light, still glows across the universe, carrying the fingerprint of that dawn. It is like a fossil of time itself, a reminder of where all ticking clocks first began. Every watch on every wrist ultimately owes its first movement to that ancient second. There's a mystery here. What happened before the first second? Was there a before at all? Some theories say time itself was created in that moment, so to ask what came before is like asking what lies north of the North Pole. Others dream of cycles, universes collapsing and rebirthing, time restarting endlessly. The truth remains hidden like a secret too vast for human minds. But even without answers, we can feel awe. Every sunrise, every hour, every heartbeat stretches back to that first second. We are living in its ripple, carried forward like leaves on a stream that began with a single drop. To think of it is to touch the deepest root of time, how cosmic expansion carries time outward. The universe is not standing still, it is expanding. Galaxies race away from one another, carried by the stretching fabric of space. This expansion is not just about distance, it is also about time. As the universe grows, so does its history. The expansion carries time forward, like a drumbeat that grows louder with every passing moment. Without expansion, time might never have unfolded the way it has. Imagine blowing up a balloon. The dots on its surface move farther apart as it grows. Each dot is a galaxy drifting away from the others. But the balloon's expansion is not in space, it is space itself, stretching. And as it stretches, light traveling through it is stretched too, turning redder, older. This red shift is how astronomers measure the expansion of time. Light itself grows tired as the universe grows larger. The expansion also sets the pace of cosmic history. Faster expansion means faster unfolding of time's story. Slower expansion means longer pauses. Our universe has balanced on the edge with just enough expansion to avoid collapse, yet not so much to tear itself apart too quickly. This balance allowed stars to form, galaxies to gather, life to emerge. The very flow of time in our world is tied to this expansion. There's something surreal here. The universe does not expand into anything. It creates more space as it grows, and with every new stretch, time itself gains new room to flow. Expansion is not happening somewhere out there. It is happening everywhere, in this very moment, even between atoms in your body, though too small to notice. The universe is always stretching, and so is time. So when you gaze at the night sky, remember that the light you see has been stretched across billions of years by expansion. The stars are not only far, they are older by the time their light reaches you. Time itself has been carried outward, painted across the sky in endless red light. The slowing of clocks near black holes. If you wish to see time bend most dramatically, look at a black hole. These cosmic giants with gravity so strong even light cannot escape, twist time into strange shapes. Near the event horizon, the point of no return, clocks slow almost to a stop. To an outside observer, anyone approaching the black hole seems frozen in time, never quite crossing the edge. Yet to the one falling in, time flows normally until the end. This paradox is real, not science fiction. Black holes show us the most extreme truth of relativity. Gravity does not only bend space, it bends time itself. The stronger the gravity, the slower the clock. And near a black hole, gravity is nearly infinite. Seconds stretch, minutes drag, hours dissolve into endlessness. To stand near one is to stand at the edge of time. Astronomers know this because of the mathematics of general relativity, but also because of what they observe. Light climbing out of a black hole's pull is redshifted, stretched by time itself. From far away, black holes appear to freeze objects near their edges. The universe tells us that time is not fixed but fragile, breaking down under immense weight. There is also beauty in this terror. Black holes preserve what falls into them in strange ways. Information may be smeared across the horizon, not lost but hidden. Some physicists believe this means time itself may have layers we don't yet understand. Black holes may not be the end of knowledge, but the doorway to deeper truths of existence. To think of a clock slowing near a black hole is to realize how local time truly is. What feels like a second here could be an eternity elsewhere. Time is not a universal beat but a shifting melody, bending under the gravity of giants, and black holes play the deepest notes of all. Event horizons where time almost stops. The event horizon of a black hole is a boundary unlike any other. It is the line where escape becomes impossible, not just for matter, but for time itself. From the outside, it appears as though anything falling toward the horizon slows, freezes, and never crosses. Time seems to halt at the edge as though the universe itself refuses to let us see beyond. Yet, for the one falling in, the crossing is quick and final. This creates a strange duality. Two realities exist at once. From afar, the traveler never enters, trapped forever at the edge. But from within, they cross easily, carried into darkness where time flows differently. Both are true depending on where you stand. The event horizon is not just a place, it is a mirror of perspective, showing us that time is not absolute, but deeply personal. Physicists believe that near the horizon time stretches endlessly. Signals from objects falling in grow fainter, slower, until they fade entirely. To us they vanish in slow motion, but to them the fall is swift. It is as if the universe tells two different stories and both are real. Time does not belong to one viewpoint. It bends to each observer's frame of reference. This mystery touches the deepest fears and hopes of humanity. What lies beyond the horizon? Is it destruction or rebirth or something unimaginable? The event horizon hides answers inside its silence. To approach it is to confront the limit of time itself, the place where the flow we know comes undone. And so the event horizon reminds us of a profound truth. Time is not infinite everywhere. It can pause, stretch, or vanish, depending on where you are. At the edges of black holes, the universe shows us the ultimate boundary, where seconds dissolve into forever, and forever into silence. The timeless silence at a singularity's heart. At the very center of a black hole lies something even stranger than the event horizon, the singularity. This is a place where the known laws of physics collapse. Density becomes infinite, gravity unstoppable, and time itself, at least as we understand it, comes to an end. To speak of before or after inside a singularity may not even make sense, for time no longer behaves like a flowing river. It dissolves into silence. Imagine standing at the edge of a map where the paper runs out. That is what the singularity is for science, the edge of knowledge, the blank space where equations fail. Our mathematics stretches to describe it, but cracks appear, showing us that something deeper waits beyond our understanding. Here, time may not exist, or it may take a form we cannot imagine. The singularity is a hidden room in the universe, locked to our keys. This silence is not empty, it is full of questions. Does time stop forever at the singularity, or does it somehow continue in a different dimension? Could another universe be born from that collapse with its own flowing time? Some physicists wonder if singularities are not dead ends, but bridges connecting one cosmos to another. If so, then time does not die there. It changes shape, slipping into another form of existence. And yet no traveller can return to tell us. Anything that crosses the event horizon is cut off from the rest of the universe. To us, it is gone, swallowed by silence. That silence may hide the deepest truths of reality, truths we may never reach. The singularity is both terrifying and sacred, a reminder that there are places where even time itself kneels and falls quiet. So the heart of a black hole is not only a place of destruction, it is also a symbol of mystery, telling us that time is not the final ruler everywhere. There are realms where its rule breaks, and in those realms may lie secrets of creation, eternity, and the universe beyond. Stars that burn for billions of years. While black holes bend and end time, stars carry it forward in slow, glowing patience. A star like our Sun lives for billions of years, burning hydrogen into helium, shining steadily across cosmic ages. Each flicker of starlight we see tonight may be from a star that began shining before humanity existed. Stars are clocks too, but their seconds are measured in nuclear fire and cosmic endurance. The Sun is about halfway through its life, a steady middle-aged star. For nearly 5 billion years it has risen every morning, its light marking the rhythm of life on Earth. For another 5 billion years it will continue before swelling into a red giant and fading into a white dwarf. To us that seems unimaginably long, but to the universe it is only a chapter. Time for stars is not measured in centuries, but in eons. Different stars carry different lifetimes. Massive ones burn hot and bright, but die quickly, in only a few million years. Smaller red dwarfs sip their fuel slowly, glowing faintly but enduring for trillions of years, outlasting all others. These tiny stars will still shine when every sun like ours has gone dark. In them we see the deep patience of cosmic time, stretched far beyond human thought. When you look at a star, you are not just looking at light. You are looking at an ancient clock, ticking in slow motion, carrying the story of time written in fusion and flame. Some stars have already ended, yet their light still travels to us. A delayed message from a past that no longer exists. Stars are reminders that the universe does not measure time as we do. It counts in billions, not in breaths. So, as we sit under the night sky, let us remember, every twinkle is not only beauty, it is time itself, stretched across eternity, burning patiently, whispering that even the briefest human life is part of this grand, endless rhythm. The long life of red dwarfs outlasting all others. Among the stars, red dwarfs are the survivors. They are small, cool and dim compared to suns like ours, but their patience is unmatched. While larger stars burn fast and die young, red dwarfs live for trillions of years, longer than the current age of the universe itself. None have yet died because the cosmos is still too young. Every red dwarf that was born still shines today. These stars are timekeepers of a different kind. They glow faintly, often invisible to the naked eye, yet they will be the last to shine when the universe grows old. Imagine a future when our sun has long faded, galaxies have thinned, and only red dwarfs remain, tiny sparks keeping time alive in a nearly silent cosmos. They are the embers of eternity waiting patiently at the edges of time. For planets around red dwarfs, this means possibility. With lifespans so long, these stars could nurture life for trillions of years, giving more time for evolution than our own sun allows. Some scientists believe the last living creatures in the universe may orbit red dwarfs, thriving while all else has gone dark. In this way, red dwarfs are not only survivors, they are guardians of life's potential. Their endurance comes from thrift. They burn fuel slowly, stretching their energy across ages. Unlike massive stars that collapse in violent explosions, red dwarfs fade gently, glowing steadily until the very end. They embody patience in the deepest cosmic sense, showing that time is not only about speed and brilliance, it is also about longevity, persistence, and quiet resilience. So, while humanity may admire the bright giants in the sky, it is the humble red dwarfs that will outlast them all. They are the eternal clocks of the universe, measuring not billions, but trillions of years, whispering softly that time is not a race, but an endless unfolding. Galaxies swirling on scales of cosmic ages. If stars are clocks of billions, galaxies are clocks of trillions. A galaxy like the Milky Way spins once every 200 million years, carrying hundreds of billions of stars in its spiral arms. From our perspective, that motion is invisible, too slow for a lifetime. Yet, over cosmic time, galaxies swirl and collide, weaving the great tapestry of the universe's history. Their rotations are the heartbeat of entire star systems. The Milky Way itself has circled only a handful of times since it was born because its years are so vast. Within it, stars orbit the center like dancers in a cosmic waltz. But galaxies do not live alone. They drift through space, drawn together by gravity, colliding and merging in slow-motion ballets that take billions of years. Time on the galactic scale is almost incomprehensible to us. It is measured in eras longer than Earth's entire history. And yet we can see this dance frozen in snapshots. Telescopes capture galaxies colliding, arms twisted, stars flung into new shapes. To us, it is a photograph. To the universe, it is a moment in a dance that will last longer than our species itself. Every swirl of galaxies is a reminder that time is not only local, it is grand, unfolding across distances and ages beyond imagination. The Milky Way, too, is part of this story. In about 4 billion years, it will collide with the Andromeda Galaxy. To us, that feels far away. To the universe, it is already underway. The merging of galaxies is not destruction, but rebirth. Stars carried into new shapes, time stretched into new stories. The universe writes its timeline not only in seconds, but in galactic spirals. So, when we see the soft band of the Milky Way above us, we are not only looking at stars, we are looking at time itself, stretched across ages, swirling in patterns too vast for our lives, yet real, steady, and patient. Galaxies are the storytellers of cosmic time, light itself carrying memories from the past. Every beam of starlight we see is a messenger from history. Light does not arrive instantly. It travels, sometimes for years, sometimes for billions of years. When you see the moon, you are seeing it as it was a second ago. When you see the sun, you are looking 8 minutes into the past. When you see distant galaxies, you may be staring billions of years back at a universe that no longer exists as it appears. Light is time's memory. It carries the imprint of where it came from, when it left, and what it passed through. Photons travel tirelessly, unaffected by age, yet telling us about ages long gone. Astronomers, in truth, are historians, reading the memories carried by light across space. Every telescope is a time machine, peering not into the present, but into the past. This also means we never see the universe as it is, we see it as it was. Every star overhead may already be gone, though its light still travels to us. Every galaxy may have changed, merged, or faded, though we still see its old face. The sky is not a picture of now, but of history painted across billions of years. We live surrounded by ghosts of light, shining as if they were still here. And yet, this is what makes the universe knowable. Without light's patience, we would never know the Big Bang, the galaxies, the stars. Light is the courier of time, carrying truths that nothing else can bring. In every photon, the past survives, refusing to vanish completely. So, when you look at the night sky, remember, you are not looking out, you are looking back. Light itself is a memory, the universe's way of telling us its story. Every star, every glow, every shimmer is a whisper from long ago, carried to you tonight.